Hi, it's Jan Beta and I'm hopefully going to repair another Commodore 64 today. It's been a while. It's been a while since I actually repaired a Commodore 64, and that's the thing I probably love most. So this one got donated by Robert just a few weeks ago, and I can't resist taking a look at it. This is the serial number, made in Western Germany, so it's probably a relatively old revision, I would guess. Yeah, we're going to see. Also, thank you, Robert, for donating this. And he also donated another MPS 801 Commodore printer. So we're going to take a look at that at some point as well. This C64 seems to be in relatively good condition. No cracks in the case visible from the outside. It is slightly yellowed, as these things tend to be. This has an interesting fault that might be super easy to fix, or it might require some digging. We're going to see. Allegedly, this turns on sometimes and gets to the basic startup prompt, but most of the times it just doesn't output anything. So kind of an intermittent fault, maybe some kind of bad contact somewhere. Let's crack it open and have a look, I guess. Let me take a few seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding, basically everything the tinkerer needs in one stop. The pricing is super reasonable, quality is excellent, so I highly recommend checking out the link in the video description in case you're interested in such services. Back to our C64. But you never know with these, really. Might be really tricky. Sometimes they are really difficult to repair. Sometimes they are really easy to repair. So is this one going to be one of the tricky ones, or is it just going to be an easy fix? Let's take a look. Okay, it appears to be in relatively original condition so far. Still has the cardboard shielding, and yeah, it's a relatively early one. 84 is the date code on the chips, as far as I can see. 21st week of 84. All the chips seem to be here. Doesn't look like there was rework done on this at all. Maybe this board never left this Commodore 64. Yeah, and I can already spot some things that are warning signs. I think it's been at least half a year or so since I actually repaired a Commodore 64. I was running out of broken ones, actually. Because I have a lot of C64s, as you probably know if you are following this channel at all. But yeah, in the meantime, I managed to repair all of them, or at least most of them. I don't know if I have any boards that are broken, but at least the C64s that were complete with the box, I repaired all of those in the meantime. This is basically the portion of the board that contains the RAM, the memory of the C64, 64 kilobytes. And there are 4164 RAM chips here, 8 of them. And some of these, as you can maybe see, are MT 4264 chips. Not all of them, and these have a reputation. These MT branded RAM chips, the 4264s, have a reputation of being super unreliable. Even right when they were new, they were not very reliable. And you see these in a lot of C64s. Unfortunately, most of them I've seen really are bad these days. And then there's the other thing that is always a warning sign, and that is the little logic chips here that are MOS branded. These are standard logic chips, but to save cost at some point, MOS, which belonged to Commodore at the time, decided to spin up their own logic chips, and they were not really good at that. So long story short, MOS spun these up in their own factory, and they are not very good. Most of these I've seen are bad in some way or the other, but these can be easily replaced with regular other brand C64 Logic Chips. You can tell that these are MOS by the logo, and they all have a 77 designator on here, 7712, 7711 and 77.7. And then we have this can here, of course, which holds the VIC-II graphics chip. There we are. That looks really clean actually, but there's no heatsink plaster on here or anything like that. So this, which is supposed to act as a heatsink with this copper tab here, I guess it didn't make good contact with the chip, so that might also be a problem on here. Oh, and I can see signs of rework actually, but it might be badly done from factory. Yeah, that looks factory. So here's our VIC-II 6569 R3, pretty standard PAL version of the VIC-II. And then I saw this, the socket for this logic chip here is soldered in at quite an angle. That's not really great manufacturing, but it looks to be original. I can't see any signs of rework on the backside of the board, other than the pins not protruding, of course. But they seem to make contact. But it doesn't seem like there has been desoldering and resoldering going on here on the backside of the board. So this is a factory flaw, I guess. I guess this originally worked when it left the factory, actually. It looks to be quite well used in general. Yeah, I think what I'm going to do is to remove the SID chip here, because I don't want to risk ruining that, and the system should start up without the SID. That is a thing I usually do before powering on, and then I'm just taking a general look at the board and look at the components and see if something got dislocated badly or shorting out, or if something is burned or has cracks or something like that. It all happens. But this one, in that regard, it looks pretty good, I think. Let's take a look. I want to see what this does when I power it on, actually. Okay, let's see how it behaves without anything connected other than the monitor. And I'm using a self-made power supply here. I wouldn't recommend using the original power supplies that these came with, because most of them are not very reliable anymore. And in case they fail, which many of them do actually, they are basically going to take the whole system with them. Because on the C64, most of the chips are supplied directly from the power supply's 5-volt rail. And that's the thing that fails often with overvoltage in these old power supplies. And in case you have overvoltage on the 5-volt rail, which doesn't have any major safety things on the board here, it's just going to pump the overvoltage into all these chips, which can take some overvoltage for a while, but not for long. And yeah, let's power it on and see what it does, I guess. Probably not much. It outputs a there we go. We have a picture. Oh, and it breaks. Okay, that's quite interesting. Okay, let's try that again, but give you a better view. No idea if this is going to start up again. Robert said it only started up sometimes. At all. Yeah. Okay. Black screen. We had the startup screen for a brief second there. Starting again. Now we have a purple screen. That's unusual. And a blue screen. Funky. And a blank screen. But it outputs a PAL signal. So, yeah. Something tries to work, and I think the VIC-II is probably fine because we saw a good picture. It should at least be able to output something. Displays different colors. Something is not starting up correctly. We also didn't have a cursor when the basic screen appeared. So this one is going to be a bit more tricky than I anticipated. And what I usually do first is to check the voltages that go through the board. On the user port, you can check the DC voltage, which should be 5 volts on these two pins here, the rightmost two pins, and the AC voltage, which should be 9 volts or a bit higher on these pins, which have the split in them. So let's check the 5 volts rail. That's 4.8. That's a bit low. This power supply should put out 5 volts straight up. So I guess some chip is damaged and pulling the voltage down a bit. Okay, this should be 9 volts AC. And it's 9.7, which is also a tiny bit low. These contacts are also pretty dirty, but 9.7 should be okay. But it also feels a bit low. So either something is dragging those voltages down a bit, or something is wrong with the power input section here. We should maybe take a look at the input section here, where the power supply is connected to the mainboard. And I'm going to check continuity, or resistance rather, on the power switch, I think, which are these contacts here. That's 140 ohms, okay, that's a bit much. Yeah, the power switch seems to have a bit of a problem here. Should be close to 0 ohms, but it is much, much higher. So this is the power switch from the backside. These 6 contacts here, and then there's 2 anchoring points basically. I think these are not even connected, or they are connected to ground. I can't remember. I think they are connected to ground. Are they? Let's find the ground. Yeah, they are connected to ground. But these don't matter. These are just connected to the casing of the switch. Usually these 2 here are the ones that get connected when the switch is on, and these 2 as well. And when the switch is off, these 2 get connected, or these 4 rather. So this gets connected to this, and this upper one gets connected to this. In the on position, we have 300, 400 ohms nearly between these 2. And this here is 0 ohms, or close to 0 ohms. So I think we might have a wonky power switch as the first thing to replace. I think I have some replacement switches still in my parts bin. Let's do that before. So just we can rule that out. It looks suspicious to me. And that might also explain the kind of intermittent behavior. So yeah, desoldering these things. And I got a replacement here. These are still available as new parts, thankfully. Just a bit difficult to find them, so you find them best in dedicated shops for C64 parts. And there are quite a few of those. Just adding some fresh solder here to make it easier to desolder. I should probably remove the little bracket here as well. And this is actually a relatively common fault. The power switches are not the most reliable on the C64 because they have a bit of lubricant in them actually. And that sometimes gets on the contacts over the years. So that's why most of these fail. If they fail, some of them are working fine. There we go. It wasn't too bad. It's a bit hot now. Most of these can actually be fixed as well. You can bend these tabs here that hold this metal part and then take the whole thing apart and clean the contacts inside. I've done that a couple of times, but as these new replacements are available, I didn't do that in a while because it's just easier to replace it. But you can totally make these work. No idea how long that lasts. I have a fixed switch somewhere in a C64. Don't even remember which one, so it seems to be still working, but your mileage may vary, of course. Yeah, this goes in here like this, just a drop-in replacement for the old switch. Fingers crossed. Maybe that was the whole thing here. Nope. Still a blue screen. Blue screen of death. I want the blue screen of life on this one. So let's try the voltages again, I guess. Yeah, that's still basically the same, I think. 4.8, 9.8. So something is pulling the voltages low there. I think the switch might actually be okay. That might just have been a red herring kind of thing here. It's not okay. Yeah, so the switch is definitely flaky. That was definitely one of the faults. That doesn't make proper contact, at least not every time. So that might explain some of the intermittent stuff. Let's check with a dead test cartridge, I think. That is always kind of my first go-to for C64s that don't output anything at all. Or colorful pictures, which I actually didn't have before, I think. Let's see if that starts up. Doesn't even really start up with the dead test. Nothing gets overly hot here. I'm just touching all the chips. Usually if you have a completely shorted RAM chip, that would get really hot really quickly. And sometimes the other chips, like the PLA, also get super hot quickly. But nothing super suspicious here. The VIC-II gets really warm. That's maybe a bit too warm. Maybe I'm going to try the VIC-II in another machine. But these run really warm even if they are right, so that might be another red herring, but still worth testing. So let's check that chip. That's always something that I like to do, check the socketed chips, because that's an easy thing to do. Let's try this in the correct orientation and turn it on. Yep, that's absolutely fine. So I'm going to put a little OK mark on that. Let's check the other voltages on the board maybe, because the voltages for both the SID and the VIC-II are generated on board and not coming directly from the power supply. We have these two voltage regulators which generate the voltages for the SID and the VIC-II. Just to have cleaner voltages, I think, is why they did that. Because graphics and sound need to have clean power supplies. Yeah, we're going to check these. You can't see the multimeter. Hang on. And we have an input pin that is the leftmost pin. We have a ground pin that is the center pin. And we have an output that is the rightmost pin on these. If you're looking at these from this direction. This should be 12 volts or thereabouts. 12.3, and this should be 5 volts. That's 4.95, that's okay. So these two are not really the problem here. So voltages are correct. The power switch was wonky, but it didn't cause this fault. Yeah, so my money is on the MOS Logic Chips and the RAM that I've shown earlier. Might also be a fault with the PLA, of course. But I tend to replace the logic chips and the MT RAM chips anyway on all the C64s. I see them in just as preventative maintenance, because basically all of these fail eventually. Interesting fault. Just displaying a random color from the color palette of the C64. Never seen that before. And it doesn't even start the cartridge. Does it start the diagnostic ROM? No. Does it reset? It does reset. Okay, that's interesting. Yeah. I have a reset button on my test cartridge here. And when I hit that, it actually tries to restart. That means it's probably nothing to do with the CPU. Oh, now we get a broken screen here sometimes. That is super interesting. So we can make this into a disco light, but it's not what we want from a C64. Most of the times. I think I'm just going to desolder all these logic chips and replace them with new proper 74 logic that I think I have all the necessary chips for in my parts bin. This is just preventative maintenance basically, and just to rule them out. So I think it probably doesn't have anything to do with the reset signal, because reset seems to work, but this might still be wonky in some other way. These two here are my main suspects, the MOS chips here, just because they are MOS chips and they are interfacing the color RAM and the RAM. I think normally this is a 7406 and that is connected to the reset circuitry, but it resets fine. Not even going to hook up the oscilloscope yet. I just want to replace these two chips with proper logic chips. I like to use hot air to get the solder melted on the other side actually. That has proven quite a good method. So that was a clean pull. Chip looks intact, and I removed the remaining solder, so I'm just going to put a socket in here. This is Texas Instruments 74 LS139AN. Should be fine. Okay, let's try. We might get a black screen every time actually, which would be actual progress. And the 7712 is a 74 LS08. Maybe that helped. As I said, I'm just, I usually just replace these without even thinking twice, because they are broken so often. We have a PAL output again, but nothing much more. That test. Nothing. Yeah, let's just replace that other MOS Logic chip while we're at it, shall we? And that's a 74 LS06 or a 7707 in MOS standard notation. So that's all our MOS Logic chips out. Let's see if that helped in any way. No. Yeah, so the next step would be to go in there with the oscilloscope. Because if it was just a RAM fault, it would definitely start up the dead test cartridge here. It's doing some weird stuff. This is me resetting it. This looks like a PLA fault maybe. That would explain why the dead test doesn't start up at all. So I'm going to start this up and probe the CPU while looking at the pinout. This should be our phi, which it is. This is the clock signal. Yeah. Then we have our ready signal. This should be high. Interrupt. NMI. AEC. This is our VCC, should be 5 volts. Yep. Then we have our address lines, and that's where it gets interesting. This is address line 1 or 0, address line 1, address line 2, 3, 4, 5, 6, 7. This all looks good. It's all pretty clear logic signals. Address line 10, 11, 12 and 13 are dead, I think. Yeah, we have some pins that are supposed to be connected to the address bus, and they're all not doing much. These are the last few address lines that the PLA is connected to that were all showing as dead. The PLA signals look rather wonky. So this might just be a bad PLA. Yeah, some of these signals look good actually, but this doesn't look great. So all the address lines going to the PLA, that's basically A13, A14, A15, didn't have anything on them. And A12 is also going to the PLA. So yeah, it might very well be that the PLA is just pulling them low. They were all just flatlining basically. Might be the processor, might be the PLA. And these are basically the only two chips that could cause the dead test cartridge not starting up. Apart from some of the logic and things like that, that might also prevent that. But usually the dead test starts up when the main chips are all right. Yeah, my money would be on the PLA because of that. Let's desolder the PLA. That's probably one of the most famous chips that breaks in the C64. Especially with these 1984, 1985 PLAs, they break all the time. So yeah, let's try. Okay, let's put a modern GAL PLA in here. That's a modern replacement chip, which should work just as well as a working real PLA. Maybe that was it. Hey! Bad PLA. As usual. That's kind of boring. So the MT RAM chips actually appear to be fine, which is rare. Des Test Max, which should be a pretty in-depth RAM test. This is the regular version, which only tests the first 4K of RAM. But usually if something's really broken with the RAM, this tells me right away. Seems to be alright, this. Bad PLA. Classic. And interestingly, the MT RAM chips that are in here, they are mixed with other RAM chips. So I suppose they had some problems and probably chose the good ones at the factory back when they assembled this. Doesn't seem like these RAM chips have been replaced. They are just in there from factory as a mixed batch. It's kind of strange to see that. So they must have chosen good MT brand RAM chips. Yeah, that test actually passed fine, except for the sound test, obviously. Because we don't have the sound chip installed, which I think I'm going to do now. Okay, I don't have very high hopes for the SID chip because these break all the time as well, but it would be really cool if this just worked. This is the first generation 6581. It's very silent. So the SID is not loud enough, it seems, but it does work in some way. That's strange because it does output sound just very silently. I'm just going to test the SID in my known good board, I think. Maybe it's the board. Let's see what this does with that. Yep, that's actually normal volume. The SID seems to be alright. Yeah, SID sounds good actually. It's the board that has some issue. It's halfway okay. At least we know that it outputs the correct volume in another board, but not in the board we are working on. So that's an issue. There are some capacitors there that have a tendency to fail on these. Maybe that's an issue with this one. Or maybe it's just the shoddy socket. So this is one of these very cheap sockets that Commodore used. They are just contacting the legs of the chip on one side. Not very reliable. And then also there's these green ceramic capacitors that often fail, really. These are known to fail sometimes. These are not so bad, the brown or beige ones, whatever you want to call this color. These green ones are known to fail quite frequently, and also these sockets. The output pin of the SID chip is pin 27, that's this one here. And that goes to this resistor here, resistor 6. And then it goes to this resistor R38, which has a capacitor, I think, soldered over it in Commodore's typical fashion. And then it goes to Q8. And I think this capacitor here is also in the path. This is an SC1815. That might be broken. That was what was suggested in the forum. However, the R6 should be a 1K, that's brown, black, red, and it measures around 250 ohms for me. And it also has a little brown spot on the side here. So it might just be that this resistor got damaged in some way. It doesn't look completely burned, and it actually has lower resistance than it's supposed to have. But yeah, that's highly suspicious. So I'm probably going to replace this resistor here first and measure that out of circuit and see if that helps. And I also measured continuity from the SID leg to the resistor, and that's fine. So there's 0 ohms resistance between those points. So that isn't the issue. The socket is not the issue, at least on that pin. And that's the output pin. I think that's what's broken here, probably. Let's see what the little resistor measures out of the circuit, actually. Should be 1K. And it is! Although it looked a bit wonky from one side. It does look wonky, so we're going to replace it anyway. Might still be something else in the queue there. Okay, let's see if that changed anything. It measured okay, but that doesn't mean much. Nope, still the same. So the next step would be the transistor, I think. And I think I have replacements for that somewhere in my parts bin. Turns out I don't have a matching transistor. I have some that would probably work, but I also have a spares board that I can just salvage some from. They use these in a number of places, and they also use different types of transistors in different boards, but this one has C1815, the exact one that is on this board. So I'm going to pull them from here and place one in here and hope that it fixes the issue with the low volume. No, it didn't fix the issue. Also going to run this with the full test harness, so maybe we can see something in the diagnostics here. Maybe the SID doesn't get the correct voltages. We're going to check that, I think, as well. Maybe something's wrong elsewhere. Oh, we have 2 bad CAAs, it seems. I'm just going to clean the connectors here and try that again. Because sometimes it's just reading things wrong. Yeah, at least U1 is bad. So we're going to have to desolder the U1 CAA. Yeah, after cleaning the contacts, it still shows CAA1 as bad, and also the keyboard and the control port shows as bad, which are connected to the U1 CAA. So it's pretty certain that that one is broken in some way. I put one that says OK from my test board in there. Let's see if that helps. OK! It now reports everything is OK, I think. But the sound is still silent. I have no idea what's going on there. But we definitely had a bad CAA there. Yeah, now reports everything as good, but we still have a low volume sound. So I'm probably going to address that in a separate episode because I'm a bit out of ideas and out of time. So far, so good. We had a broken CAA. We had a broken PLA, surprise, and I replaced the MOS Logic Chips. That was kind of a red herring. I guess they are all fine, but always better to replace those because they are not very reliable anyway. So yeah, I'm not sure what that SID problem is, but yeah, it might still be one of the caps or something like that, or a break in a trace somewhere, but I can't see anything. But I didn't measure it in detail because this video took long enough to make. So I'm probably just going to call it a day at this point. At least the machine is up and running again. It seems to perform as expected except for the sound. Yeah, I hope you enjoyed this kind of 3/4 of a repair of a C64. I am going to get back to this and figure things out, but yeah, I'm a bit exhausted. And we at least got it up and running again. SID is not loud enough for whatever reason. We're going to see what that is. Thank you so much for your time. Hope you enjoyed this. Special thanks as usual to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links to that are on my website and in the video description. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.